All right, chemistry, let's take a look at number 8. I'm going to get into some actual calculations here, so make sure you have your periodic table out. If you don't, you know what I consider you. Number 8, determine the mass in grams of each of the following. 3.00 moles of aluminum. And so what we are given to start with, 3.00 moles of aluminum. Now, just like we did in Chapter 2, if I'm going to cancel moles of aluminum, I need to have that as the denominator in my conversion factor. But I need to end in grams. Luckily, there is a number that relates grams of aluminum to moles of aluminum. It's called molar mass. And so I get out my periodic table, and I see that aluminum has a molar mass of 26.98 grams per mole. What was that? 26.98 grams per 1 mole, right? In 1 mole, there's that much mass. And I now have what I need to plug into my calculator. So, get my calculator in here. 3.00 times 26.98. We end with 80.09 grams of aluminum. Now, going back to significant figures, my calculator actually gave me 4 digits here, 4 figures, but I need to report my answer in terms of 3 significant figures because of the number given to me by the question. And so I'm going to round to this 9. This 4 tells me that I'm going to leave that 9 as it is, not round it up. And so the answer that I report is 8.09 grams. Sorry. Oh, goodness gracious. I put the decimal in the wrong spot. Just erase that. 80.9 grams of aluminum. My bad. All right. B, we're actually going to use 2 separate conversion factors because I'm given atoms of lithium. And so I'm definitely going to want to convert out of atoms of lithium. But the only thing that I can convert from atoms of lithium into are moles of lithium. But the question is not asking for moles of lithium. The question is asking for grams. And so after I've gotten my value in terms of moles, I'll do one more conversion factor to go from moles to grams. Now I'm in grams. Now we can double check to make sure that this works out. My atoms of lithium will cancel with each other, and my moles of lithium will cancel with each other. So the only unit I'll have left is grams of lithium. So let's plug in the numbers that we need. So 2.56 times 10 to the 24th atoms. In any 1 mole, there's 6.022 times 10 to the 23rd atoms of something. Let's go to the molar mass of lithium. In any 1 mole of lithium, there is 6.941 grams of lithium. And now I'm ready to calculate. Let's see. Let's use this calculator. It's probably easier to see. Let's put it over here. So 2.56 times 1 times, goodness gracious, did I already miss a decimal? 2.56 times 1 times 6.94. Goodness gracious, 6.941. And then we are going to divide that by 6.022. All right, so the value that I'm going to get is 2.95. I want 3 significant figures, so yeah, 2.95 is what we'll stick with there. Now, in terms of these exponents, I have a times 10 to the 24th. That there for now. I have a times 10 to the 24th over a times 10 to the 23rd, and so I'm going to be left with times 10 to the 1st. Okay, when you divide 2 exponents, you subtract those exponents. 24 minus 23 is 1. So I'm going to be left with that value, which was 2.96 4.95 times 10 to the first grams of lithium. Now, you can keep that as the answer that you report, or you could just move the decimal 1 over because of the times 10 to the first, then be 29.5 grams of lithium. That's also fine. C, 1.38 have moles of nitrogen. I want to convert away from moles of nitrogen, so that's on the denominator. I want to go into grams of nitrogen, right? And so now, then I go back and fill in my numbers. For every 1 mole of nitrogen, 14.007 grams of nitrogen. And time to calculate. .3. Let's see. Yeah, 3 significant figures there. 3 significant figures. Grams of nitrogen. Because my moles cancel, my only unit left is grams of nitrogen. Now we have another problem, just like B, where we're given atoms of an element, but we still want to go all the way to grams. So we're actually going to set up the conversions in the same style. We're going to start with atoms of gold. Have atoms of gold on the denominator as well, so that we can get into moles of gold, and then from moles of gold we can use the molar mass to go to grams of gold. Alright, so we have our units set up correctly because those two will cancel. These two will cancel, and the only unit I'll have left is grams of gold. So now it's time to go back and actually plug in the values. 4.86 times 10 to the 24th atoms. In any 1 mole, there are 6.022 times 10 to the 23rd atoms. In any 1 mole of gold, 196.97 grams of gold. Now it's all that's left to do is use my calculator. 4.86 times 1 times 196.97, and we're going to divide that by 6.022. Now we're going to want, let's see, looks like 3 significant figures, so we'll go with 159. Now what do I want to do about these exponents here? So this is 24 minus 23. Alright, so we can either say, this probably isn't going to be a good notation because this is not in proper scientific notation. We go 1, 2, so we'd either go 1.59 times 10 to the 3rd grams of gold, or either one of those versions are going to work. You have the appropriate number of significant figures. This is proper scientific notation. This is standard notation. Either of those are okay, unless, of course, the question specifically asks you to use scientific notation. Moving on to E. Okay, we're given moles of copper, and so moles of copper need to cancel. Therefore, I'm going to put that on the denominator. I'm going to go into grams of copper because that's what we've been asked of for this entire problem. Now that I know that copper moles will cancel out, I know I'm set up correctly. So now I'll plug in the actual values. I know for every 1 mole of copper that I have, let's see, I have 63.55 grams of copper. And now it's time to calculate. 6.50 times 63.55. End up with, let's see, I'm going to want 3 significant figures here, right? So I'll just go, yeah, stay the same. So 413 grams of copper, right? No exponents, no need to move a decimal. Just come up with 413 grams of copper. Next up, I'm given moles of sulfur, so we're going to use sulfur moles. We haven't used those anytime recently, so this will be a new element. But regardless, I've been given moles of sulfur, so I know that those need to go on the denominator as well, because that's the only way they'll cancel. Then I can go to grams of sulfur. I know that those are set up appropriately. Let's put in what the question gave us. Now to the periodic table for the molar mass of sulfur, 32.06 grams per mole for 1 mole, and calculate. 2.57 times 32.06. Now I'm only going to want 3 significant figures here, so I'm just going to go ahead and round this to 82.4. But then I have my times 10 to the 8th, which isn't going to be affected because there aren't any other exponents over here, times 10 to the 8th grams of sulfur. But this isn't proper scientific notation, and it's not standard notation. So I'll either go 8.24 times 10 to the 9th. And that's probably going to be our best version, because putting that into a standard notation is going to be a really, really long number. So 8.24 times 10 to the 9th grams of sulfur. Last one. Again, another situation where we're given atoms. This time it's of mercury. So atoms of mercury into moles of mercury. And then from moles of mercury into grams of mercury. And again, how do I know this is correct? Because atoms cancel with atoms, moles cancel with moles, and I'm left with grams of mercury. So let's plug in what I've been given. Times 10 to the 8th. I know for every 1 mole I have 6.022 times 10 to the 23rd. And I know for every 1 mole of mercury I have 200.59 grams of mercury. And it's time to calculate. 1.05 times 200.59. And I'm going to divide that by 6.022. Let's see, I'm going to want 3 significant figures, so I'm going to go, looks like I'm going to have to do 35.0. Use my exponents here. I have 8 minus 23. So that's going to be to the minus 15th grams of mercury. That's not quite in proper scientific notation. That's too big. So I'm going to go 3.50 times 10 to the negative 14th grams of mercury.